Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important, that is burning science and technology issue. This technology belongs to the space. So what is that? Once you have to see extreme nuclear transient, extreme nuclear transients. First you have to take how they are forming the extreme nuclear transients. Once you have to see an unlucky massive star approaches a supermassive black hole. An unlucky massive star approaches a supermassive black hole. This is the first one. The star gets stretched by the intensive tidal forces, eventually being ripped apart in a tidal disruption event. This is the second one. Now you have to see an accretion disk forms around the black hole, powering an extreme nuclear transient. This power generated due to the extreme nuclear transient. An infrared echo tells us that the dusty torus surrounding the central black hole and newly formed accretion disk. So this is the newly formed accretion disk, it will help. So therefore after some time what will happen, the ENT, the extreme nuclear transient, outshines the entire stellar output of its host galaxy for nearly a year. So nearly a year it will shine like that. So after more than a year, accretion onto the black hole slows and ENT fades will happen. These are the extreme nuclear transients introduction. Once again you have to see an unlucky massive star approaches a supermassive black hole. An unlucky massive star approaches a supermassive black hole. That is the first one. So after approaching, what happened? The star gets stretched by the intense tidal forces, eventually being ripped apart in a tidal disruption will happen. An accretion disk forms around the black hole, powering an extreme nuclear transient. An infrared echo tells us that a dusty torus surroundings the central black hole and newly formed accretion disk. So this newly formed accretion disk, what happened? The ENT outshines the entire stellar output of its host galaxy for nearly a year. After more than a year, so accretion onto a black hole slows and the ENT fades. So this story is under the burning issue and all these days, that's why I chose this one. So extreme nuclear transients are newly discovered, a class of cosmic explosions even more powerful than the gamma ray bursts, so which are most intense flashes of electromagnetic radiation. So these are extreme nuclear transients recently scientists discovered by the cosmic explosions studying, even more powerful than the gamma ray bursts, so which are the most intensive flashes of electromagnetic radiation. So what are the ENTs? In astronomy, transients refers to celestial objects whose brightness changes significantly over a relatively short period. Extreme nuclear transient phenomena occur when massive stars at least 3 times the mass of our sun are torn apart by supermassive black holes at the centers of the distant galaxies. The resulting explosions release energy equivalent to what 100 suns would emit over their entire lifespans, making them visible across vast cosmic distances. So this is the what is the energy it will deliver. So 100 suns energy at a time it will come. So those energy also smaller energy. So because of this ENT, so the extreme nuclear transient energy, it is a massive explosive star. Clear? So that is the thing. So, Gaia 18 CDJ, it is the most energetic ENT studied. It released over 25 times more energy than the most powerful supernova ever discovered. So, more than the amount of energy that would be released by 100 suns throughout their entire lifetime. So, 100 suns throughout their entire lifetime, how much energy is giving? So, that much of 25 times energy it will give. This is the ENT, extreme transient, in nuclear energy states. So, ENTs traverse immense distances and remain luminescent. So, remain luminous in radio wavelengths for years, making it possible for astronomers to study them. So, it can travel immense distances and remain luminous in the radio wavelengths for the years. These ENTs will give the radio wavelength. Is there any help ENTs to human body? So, they help scientists study the supermassive black holes in the early universe. So, they may explain how galaxies and black holes grow. The future telescopes like Rubin Observatory and Roman Space Telescope will make it easier to spot more ENTs. So, is there any ENTs is observing? So, these telescopes will observe. Rubin Observatory and Roman Space Telescope will make it easier to spot more ENTs. These are the very useful to study the supermassive black holes and to explain the galaxies and black holes to grow, how it is growing. So, those things also to explain. So, because of these telescopes we have to see all these things. These are the very interesting thing. It is a very powerful energy source we are seeing. These are the heads up to the scientists. So, this is a gamma ray bursts. So, more powerful till now. Now, they are coming. Extreme nuclear transients are more powerful radiators, clear, in the universe. So, please share and subscribe and like our YouTube channel. Like these videos, I will upload in our YouTube channel daily. Listen and enjoy. If you want to write in competitive examination, it will help you in your competitive examination. Otherwise, you have to learn about the science and technology. In your life also, science and technology takes place major role. Thank you so much.